Welcome to homework.
Alright guys, doing problem 130, chapter 11. An aqueous solution is 1% NaCl by mass and has density of 1.071 grams per cubic centimeters at 25 degrees Celsius. The observed osmotic pressure of the solution is 78.3 atm at 25 degrees Celsius. What fraction of the moles of NaCl in the solution exists as ion pairs? So we can do this with the formula I is equal to mRT divided by pi, where I is going to be the moles of particle in the solution divided by the moles of solute dissolved. So that could be the moles. So that's going to be the moles of our ion pairs divided by the total moles of NaCl dissolved. So M is going to be the concentration. R is going to be the ideal gas constant, 0.08206. St is going to be the temperature in Kelvin, and pi is going to be our pressure. So let's find the concentration. So let's look at our density, 1.071 grams per cubic centimeter. So that means that we have 1.071 grams per cubic centimeter of our water. That means, so if we have 1% NaCl by mass, that means 1% of that mass per cubic centimeter is due to NaCl. So we can multiply that by 0.01. We can then just convert the mass of NaCl to moles, 1 mole per 58.5 grams. And then you multiply that convert that to the cubic centimeters to liter. So there are 1,000 cubic centimeters in 1 liter. So that means M is going to be 1.071 times 0.01 divided by 58.5 times 1,000. That's going to be 0.18 molar. Next, so I is going to be 0.18 molar times 0.08206 liter atm per mole Kelvin. We're doing this 25 degrees Celsius, so that's 298 Kelvin. So that's 7.83 atm. So that means I is going to be equal to 0.56. All right, next, calculate the freezing point observed for this freezing point that would be observed for this solution. So we know the freezing point of water is 0 degrees Celsius. Celsius. So now we're going to use this formula. Delta T is equal to KFM, where KF is going to be the freezing point depression constant, and that's dependent on the solvent. In this case, it's going to be 1.6. So delta T is going to be the 1.6 kilograms times degrees Celsius per mole. And then we're going to multiply that times the molality of the solution. So remember what molality is. Molality is going to be the number of moles of solutes over kilograms of solution. So we have 1 gram per NaCl. over 100 grams. So 1 gram divided by 100. And so now multiply that by convert gram to kilogram. So that's going to be so they're 1,000 grams per kilogram. And then we convert the top gram to moles. So we do 1 mole divided by 58.5 grams. That means delta T is going to be equal to 186 divided by 100 times 1,000 divided by 58.5. And just to be sure, these grams cancel out, kilograms cancel out with kilograms, moles cancels out with moles, and grams cancels out with grams. So delta T, that's going to be equal to 0.32 degrees Celsius. That's how much the temperature is going to decrease. So that means that the free point for this is going to be 0.32 degrees Celsius below 0 degrees Celsius. So that means T is going to be minus 0.32 degrees Celsius. Because remember, when you add a salt, freezing point decreases.